Most cyclists around the world own at least one of these inexpensive bike lights. They cost less than €2 each and are powered by two disposable CR2032 batteries. Although the light they emit is not very bright, they work well enough until they get stolen or run out of batteries. Many cyclists are aware that the cost of replacing the two coin cell batteries in their bike lights is often more expensive than the light itself, so that they are often discarded when the batteries run out. This video will demonstrate how to power your inexpensive bike lights with a power bank, eliminating the need for disposable batteries. If you are motivated by this project or if you like my videos, please support my work by following my channel. Thank you very much. First, I took everything apart to see what's inside. The circuit is basically non-existent. There is probably a single IC underneath this white resin. Checking with the multimeter, it looks like the LEDs are connected in parallel. This surprises me a bit because the two coin cell batteries in series supply a voltage of 6 volts. Since the two LEDs are about 3 volts, I thought they were connected in series. Before making this video, I tried to connect the circuit directly to the power supply. This was not a good idea. In fact, the power supply current reached more than 300 milliamps in 1 second and the light stopped working. As you can see, the circuit does not work now. It seems that these lights need a limited current supply to work properly. I have no idea what current the CR2032 delivers, so I bought these brand new lights to take some measurements and figure out how best to set the supply current. These new lights are almost identical to the ones I destroyed with the power supply. Now all I have to do is pack the batteries and take some measurements. The batteries are charged as I expected. About 607 volts. To understand the behavior of the batteries, I connect the multimeter to the positive terminal between the battery and the light and set the multimeter to ammeter mode. I did some quick tests. In the first mode, when the light is steady, the batteries deliver a peak current of about 70 milliamps, and after a few seconds the current drops and stabilizes between 20 and 25 milliamps. In the other two intermittent modes, there are no current peaks and the average current is definitely less than 20 milliamperes. While powering the circuit with the power supply, I found that the initial current spike is not critical. In fact, by setting the voltage to 6 volts and limiting the current to 20 milliamps, the light works fine. As I said at the beginning of the video, I want to power these bike lights with an old power bank that usually delivers 5 to 5.2 volts. By changing the voltage of the power supply, I found that from 4 to 6 volts the circuit works with good brightness. At 2 volts the circuit works but the light intensity drops a lot. This means that we can power our bike lights with either a power bank or a single-cell lithium battery at 4.2 volts. Well, now we have all the data to complete our project. Since I am lazy, the easiest way I can think of to regulate the current is to use a resistor between the power bank and the light circuit. I use a variable resistor. Code 101 means the potentiometer is a maximum of 1 kilo ohm. By turning the screwdriver in a few seconds I found the right resistor, which produces 5 volts at 20 milliamps. Out of curiosity, I measured the resistance with the multimeter. It is about 115 ohms. Now to complete the project we need 2 electrical wires and a micro USB connector. You can find all the materials and tools I used in the description. I solder the 2 wires to the battery terminals. In order to assemble everything cleanly and functionally, I designed and printed this small item. It fits nicely into the battery housing and will be used to secure the micro USB connector and to preserve the curve of the light shell. Now we take heat shrink to protect the contacts and remove the unused contact from the potentiometer. I shorten the wires a bit and solder the resistor we adjusted earlier to the positive terminal. I apply the heat shrink and heat with the hot air gun. This looks like a pretty clean job. Now we gently press the wires and the potentiometer into the battery case. I use some hot glue to seal everything and use the micro USB connector as a cap. Now I solder the black wire to ground and the red wire to the V-bus pin. As a last step, I took a piece of rubber from a used inner tube to create a round seal. It is used to keep the light on the bike and to protect the contacts of the USB connector. I fix everything with hot glue. We have completed the assembly of our light. Now let's try a test. I take my old power bank and a micro USB cable. And of course the light we just modified. Wow, it seems to work fine. The light is bright and seems to work well in all modes. But wait, why has the light stopped working? What is happening? Try and try again, it is always the same problem. Everything works fine for a few seconds and then the light goes out for no reason. While doing some research on the web, I found that all power banks automatically shut down when too little load is connected. Each power bank has a different minimum threshold of up to 100 milliamperes. Our light stopped working because the power bank I was using definitely had a threshold higher than the 20 milliamperes consumed by our small light. At this point, how can we solve this problem? Solution 1. Check out this video from my favorite YouTuber GreatScott. Some time ago he made a brilliant video on how to solve this problem. I highly recommend you watch the video and follow this brilliant creator. Solution 2. For testing purposes, I connected a 20 mA LED with an appropriate resistor to a USB cable. As you can see, the LED stays on for 30 seconds and then goes off. I stole my mom's power bank to see if it behaved the same way. This power bank disconnects for a fraction of a second every 5 seconds or so. Other than that inconvenience, the power bank does not shut down and continues to work normally. Even with the light plugged in, it works perfectly. So one solution might be to try different power banks until we find the right one. Solution 3. Just use a rechargeable battery. As you can see, I used a step-up regulator soldered to a battery holder. If you want, you can avoid this and use a battery directly. The important thing is to adjust the resistance of the circuit accordingly, since the battery has a voltage of 4.2 volts and not 5 volts. This solution will certainly guarantee you perfect operation and avoid any sudden shutdown. Now all we have to do is install our handy rechargeable light on our bike. The work is very clean, safe, and waterproof. Thank you all for coming this far. My name is Dario and I am a maker. If you liked this video, please share it with your friends and follow my channel. Ciao ciao.